Hello, let's look at number 12, last question. Almost there, so good job. It's really good to get all the way here. I'm glad you're here. Last question. Hopefully you've been able to kind of learn and see some different ways to solve problems. Remember, it's all a process, getting better each day, and just being able to figure out how to connect different ideas and being able to answer questions, right? It's not necessarily something that's going to happen overnight, but you just keep practicing, and I promise you'll be able to get there. So a heavy block of mass 4.5 kg is initially at rest at the edge of a 1.2 high frictionless table. The table has a length of L equals 2 meters. A light block of A of mass 0.4 kg slides across the table at a speed of 25 meters per second and strikes block B, causing block B to leave the table in the direction in which block A was moving. The figure below shows a graph of the force exerted on block B by block A as a function of time. So part A, determine the impulse given to block B. Okay, so we have this lovely graph, and so we're going to go ahead and try to figure out the impulse, right? So impulse just equals what? It's force times time, but remember the calculus definition is what? The integral of force dt. And so what we're really looking at for in this graph is what? Yeah, we're looking for the area under the curve, okay? So basically we're trying to add up the entire area under the curve. And so we can look first of all at this triangle here, okay? So this triangle here would be, it's 4, it has a height of 2, so we'd have 2 times 4 times a half, because we're trying to find a triangle, and so that would just be 2 times 2, so this would be a 4, okay? And you'll notice that this triangle over here is actually the same area, so that's also got to be a 4. And then here we have a length of 2, and then we have a height of 2, so this will also be 4. And so the total area will just equal 12, okay? And so we know that the total area just equals 12. So not too bad for that first part, okay? But remember, we do need our units. So it's force times time, so that'd be Newton seconds, okay? So that one was just finding the area, making sure we knew the definition of impulse. So let's go ahead and look at part B. It says, determine the horizontal velocity of block B immediately after the collision, okay? So this would be one where we can just go ahead and work off what we used in A, right? One of the biggest clues you can have in some of these multi-step questions is whatever we did in part A may help us with part B, right? So we know that our impulse, J, is equal to the change in momentum. Okay, so we have, that gives us 12 equals the change in momentum, which is just M, VF minus VI. And we know that VI is just 0 because it's starting from rest. Okay, so we have 12 equals, and then our mass is 4.5. 4.5 times VF. So VF is just 12 divided by 4.5. Okay, so we have VF equals 2.67 meters per second. Okay, so hopefully not too bad so far. We've been able to get 2 answers pretty easily. I don't think those should have been too bad for us. Okay, but let's go ahead and move on to C. Okay, so it says, determine the following for block A immediately after the collision. I is the speed, and then II is the direction, so left or right. Okay? And so for this one, I think the easiest, well, there's 2 ways, right? So we can set up change in momentum equals the change in momentum, right? Or the total momentum at the beginning, is equal to the total momentum at the end. And that's one way, and that's fine. That's wonderful. But to me, it feels like you can also just, maybe a little bit easier, to just do the impulse is equal to the change in momentum, right? We know that the force here is going to be equal to the force, right? As 2 objects touch each other, if I push on an object, it pushes back on me with the exact same amount. So the impulse felt by block B is also the impulse felt by block A, except for it will be in the opposite direction. Okay, so I have a negative 12 equals the MVF minus VI. okay? And here, VI is not 0, okay? So I'll have negative 12 equals my mass is going to be 0.4. 0.4, and then I have VF, which is going to be what I'm looking for, minus VI, which is the initial velocity of that block, which was 25 meters per second. Okay, 25. Remember, the reason I had to make this a negative is because it's in the opposite direction, right, to the left. So if I draw a scale here, to the right is plus, this way is minus. All right, we're keeping with the same scale we had earlier where it was plus minus, right? And so if it's causing, if block A pushes block B to the right, block B pushes block A to the left, right? And so that impulse is the exact opposite, sort of Newton's third law. Okay, so let's go ahead and work to solve VF. So I have negative 12 equals 0.4 VF minus 10. And so I will go ahead and add 10 to the other side. Okay, so I get 2 equals 0.4 VF, and so VF just equals 5 meters per second. Okay, and so that gives us the final velocity in the final velocity for that second thing, and we know that it is still negative, right? I actually made a mistake here, right? This is negative. I add that 10, I get negative 2, so this is a negative. And so part I says it's speed. Remember, speed does not have a direction, okay? So for part I actually want to actually get rid of that 5, and then for I'll say to the left, okay? This number is slightly off from the answer key number, but the answer key number is 5.04, so I think that's kind of a rounding thing from something else. It could be a difference between using the momentum, conservation of momentum, and also using this, okay? But that's close enough that I wouldn't worry too much about that difference, okay? So let's go ahead and look at D. So D says determine the kinetic energy dissipated in the collision. Okay, so this is just kind of what we've seen before, where we have KEI minus KEF. Okay, so KEI, that's just going to be our initial, so 1/2 mv squared minus 1/2. This will be 2, right? I actually have 2 masses, and so I can't just add the masses together. I'm going to have mv squared minus 1/2 mv squared. Okay, this is sort of my total, okay? This will be maybe A, and then this is B, right? Because I have 2 things moving, so I need to add both of those kinetic energies there, or subtract both, right? And so I'll have 1/2, my my block A has a mass of 0.4, and then its initial velocity is 25, so I gotta square that, and then 1/2, this I'll say is block A. So remember, block A is the smaller one, so this will be 0.4, and then the velocity of that one was 5 squared, and then minus 1/2, this one was significantly heavier, so that was 4.5 kg, and then my velocity was 2.67 squared, okay? So I have 0.5, let's go ahead and type some of this into the calculator. So you get 125. This one is just 5. Okay, so I have 125 minus 5 minus 16. So this equals 104 joules. Okay. So once again, it's a few decimal places off the answer key, but that's not really something to worry about. That's just sort of a rounding thing. So don't worry too much about that. Okay. So that would be our energy dissipated. Okay. And let's look at part E. So it says determine the distance between the 2 points of impact of the blocks with the floor. So basically this is saying I have my table here. This block is going to end up going this way. This block is going to end up going this way. And then this will land here and this will land here, and it's saying how far apart will these be? Right? Okay. So let's go ahead and try to figure that out. Now, the first thing we need to know is the time, right? I need to know the time that both are going to fall, right? When I have that time, I can figure out how far will this one go, right? Delta x for the B block. Then I also need delta x for the A block, right? And then I also have a length here, the length of the table, right? And the length of the table is just 2 meters. Okay, so I'm going to have to add up each one of those things to find the total. But I need to do my y part first, right? I need to find out the amount of time it takes to fall so I can find out the distance in the x direction for both. Now, you could set up an xy chart for both of them, but it's a little bit easier just to think of what's the time they're in the air for both of them, because we know that time will be the same, and then solve for the distance from there. Okay, so we have our VIY for both is going to be 0, right? Because the velocity is only in the x direction, not in the y direction at all. AY is going to be negative 10 meters per second squared. And then we also know that the delta y is equal to, well, let's find out what the height of that table is. So the height of the table is 1.2 meters. 1.2 meters, and then we need to find the time. Okay? So the formula, you can look on your formula sheet, but the best one will be delta y. I'm changing that delta x into a delta y. VIYT plus 1/2 AT squared. Okay? So we have 1.2. This whole part is going to go to 0 because our initial velocity is 0. Equals, I did make a mistake. This is going to need to be 0 if my acceleration is 0. Alternatively, we can set both equal to positive if I'm setting down as positive and up as negative. Okay? So then it would be 1/2 10t squared. So I have 5t squared equals 1.2. So I have 1.2 divided by 5. So t squared equals 0.24. And then I will take the square root of that. Okay? So t equals 0.489. Okay? Try not to round too much. That may be what I've been doing, but don't worry too much about that aspect. College Board is less worried about that and much more worried about how you're solving your questions. Okay? So let's go ahead and look at this delta x for A. So delta x for A is going to be equal to, we're going to use that same formula. So I'll have VIX times t plus 1/2 AT squared. I know that this part is all going to go to 0 because the acceleration in the x direction is 0. So I have delta x A equals VI. So the velocity of that block would be 5 times my time is 0.489. So this delta x A is going to be equal to 2.45. Okay. Next, let's go ahead and do this delta x for the second block. Okay. And so this delta x, we can just use the exact same formula, VIX t plus 1/2 AT squared. This whole part goes to 0 because A is 0 in the x direction. And I have delta x b equals VI. My initial velocity of that block is going to be this one. Okay, so 2.67. Sorry about that. 2.67 times the same amount of time, 0.489. and we get delta xb equals 1.3. Okay, so now all I need to do is just add up all those numbers together. Okay, so I have delta x equals 2.45 plus we have a 2 meters here. Okay, so plus 2 plus 1.3. So 2.45 plus 2 plus 1.3. And so I get delta x equals 5.75 meters. Okay, and that would be my final answer. Okay, once again, it's slightly off the answer key, but that's not something to worry about. That could also be that they used 9.8 for G instead of 10. Okay, but that would be your answer. So thanks so much for sticking with it and being able to complete all these questions is definitely going to serve you well. One thing you can always do is come back to a question later, especially if you get stuck on it, or you finish it, you're able to figure out the answer, but come back to it maybe a couple days later or next week after Thanksgiving break, and it might give you a chance to look at it and see if you can solve it without knowing exactly how to solve it, right? Maybe a little bit of memory, but not exactly a complete memory of how to solve it, and that will give you some great practice. Just doing more problems, getting a chance to see more problems, that's really what's going to benefit you in the long run. So thanks again for sticking with it, and I'm so proud of you. Good job.